morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today I am going to discuss a topic about industrial substation. These are the few key points like introduction to the industrial substation, key components which are being used and different types of substation, the working of industrial substation, as well as its design considerations, safety measures, and monitoring and control systems, its applications, its challenges, and future trends of the industrial substation. The first one is introduction to the industrial substation. Here we can see the definition. An industrial substation is a facility that converts high voltage electricity to low voltage levels. Industrial substation means it converts the high voltage electricity to low voltage levels, which is being suitable to that particular industrial use and ensures the distribution of electrical power to factories as well as the plants and other industrial complexes. Okay. So for industries, factories and for other commercial buildings, the industrial substation reduce the voltage which is being taken from the high tension wires. The voltage is being reduced using the step down transformer and that voltage is being connected to the industrial use. Next one is purpose. What is the purpose? To step down the voltage for local use. That means the high tension voltage is mostly more than 660 volts. That is 11 kilovolts or 33 kilovolts. So this voltage is being reduced based on the load, that is based on the load. The load may be an industry or a factory or commercial building. So based on the load, based on the voltage level of the load, the voltage is being reduced from the 11 kilovolts or 33 kilovolts by using a step down transformer, and that particular voltage is being connected to the loads, that is consumers, that is industries or factories. So the purpose of this industrial substation is to reduce the voltage level based on the local use. Next one, to control and distribute electricity to various processes or machinery in the industry. To control and distribute electricity to various processes and for the machinery in the industry. The third purpose is to ensure the reliable power supply with safety, protection and efficient distribution. For safety, protection and for the efficient distribution. So these are the different purposes of industrial substation. Next one is key components of industrial substation. What are the key components? The first one is transformer. As I said, the high tension voltage is being stepped down or reduced to the voltage which is being required by the industry or factory. So a transformer is needed. Mostly a step down transformer is needed. Second one is switchgear. Switchgear components are like different protection devices. So different protection devices like circuit breakers, disconnectors, fuses and etc., which can protect the device from different types of faults. The third one is bus bars. Conductors used for collecting and distributing power supply. Bus bars are nothing but the conductors which are used for collecting as well as distributing electrical power. Fourth one is protection systems. Protection systems like relays, fuses, circuit breakers. Fifth one is control panels, which is used for monitoring and controlling the electrical system, which are used for monitoring as well as controlling the electrical system. The sixth one is capacitors, improve the power factor and system efficiency. Capacitors are used to improve the power factor and systems efficiency. The seventh one is the earthing systems, different grounding or the earthing systems in order to protect the device. So, prevent electrical hazards. In order to prevent from the electrical hazards, we need to properly ground or earth the system. What are the different types of industrial substations? The first one is step down substation, step up substation, switching substation and distribution substation. So, first one, step down substation. It is used to reduce the voltage from high levels. It is used to reduce the voltage from high levels to usable levels of the industry. To usable levels of the industry or the commercial applications, commercial buildings. The next one is step up substation. It is used for boosting. Boosting is nothing but increasing. Boosting is nothing but increasing. So, it is used for increasing the voltage of transmission levels for long distance power transfer. In order to transfer the power for long distances, we will mostly step up or increase the voltage. The third one is switching substations, used to switch between different circuits and control the flow of electricity. It is used to switch between different circuits and control the flow of electricity. The fourth one is distribution substation. It provides power to a specific area. It provides to the specific area for a longer transmission network. Next one is working of an industrial substation. What is the working of industrial substation? The first one is incoming power. Second one is step down transmission, switching protection, distribution and monitoring and control. So, first one, incoming power. The high voltage electricity from power plants or the transmission lines. That means from the electrical plants or from the transmission lines, we will be having a voltage of 11 kilovolts or 33 kilovolts or 132 kilovolts. So, this particular voltage we need to step down based on the load. We need to step down by using a transformer, mostly power transformer, to reduce the voltage based on the industry or the factory. So, this is nothing but the incoming power which is being taken from the transformer, which is again connected to the high tension wires. Next one is step down transformation. Voltage is stepped down by using a transformer to a level which is being useful for the industrial use. So, as I said, from the HT wires, from the high tension wires, which are mostly of this particular voltage, is being stepped down to a voltage which is being connected to the industrial use. Switching, third one is switching as well as protection. The switchgear and the protection system control to safeguard the electrical supply. In order to protect the electrical supply or in order to protect the different components which are being connected in the industrial area, we need to connect different types of switching as well as protection devices like circuit breakers, fuses, relays and all. Next one is distribution. Distribution means power is distributed to various loads. That loads may be motors, machinery and lighting systems. The loads may be different motors, machineries as well as lighting systems in a particular industry or a factory. Next one is monitoring and control. Monitoring and control. The SCADA system is mostly used for monitoring and controlling the device in an industry. What is substation design considerations? What is substation design considerations? Here there are different types of considerations which are to be considered from the substation. That is, first one, load requirements. The substation design must meet the power demands. The substation should meet the demand of the industries considering both present as well as future needs. That is, present load plus future demand should be considered before itself. Based on this, the voltage level should be decided, and based on this voltage level, we need to take the wires or cables from substation using a transformer. Next one is location. The proximity to the factory or industrial area. Based on the location of the factory or the industry, we need to connect the industrial substation. And the access of transmission lines as well as ease of maintenance. That means in order to maintain do regular maintenance, we need to have a proper access to the transmission lines. Third one is safety standards. Substation must comply with national as well as international safety standards, that is IEC or IEEE standards. So, in order to maintain these IEC as well as IEEE standards, these substations should follow the rules and regulations, and proper grounding as well as fire protection devices and fault protection devices has to be connected in the industrial substations. Next one is reliability. The redundancy in components like dual transformers ensures continuous power supply in case of failure. In case of failure, we will get a continuous power supply, so that reliability should be considered. Next one is environmental impact. The noise as well as cooling or heating effects, reducing the visual impact of the substation in industrial settings should be done. So all these 5 things should be considered for industrial substations. Next one is safety measures in industrial substations. What are the safety measures to be taken? Like, first one is earthing or grounding. Proper earthing or grounding based on the load voltage level should be done, which ensures the safe dissipation of fault current into the earth. Whenever there is a fault, fault occurs, a proper the current should be properly grounded or should be sent back through the earth. This is for preventing the electrical shocks. Second one is circuit protection. Use a circuit breaker, but that is by using different protection devices like circuit breakers, fuses, relays, disconnectors should be used at different points in order to protect the device. Next one is fire safety. We should consider fire safety, that is installation of fire extinguishers. Installation of fire extinguishers, fire barriers and proper ventilation to prevent the fires. Fourth one is PPE, that is personal protective equipment. Personal protective equipment. Workers must use this PPE, that is rubber gloves, boots and face shields during the maintenance or during the repair works. During the installation or during the maintenance or during the repair works, the workers should be provided with proper PPE kits in order to protect the worker. Next one is warming signs. That is, high voltage areas must be clearly marked with warming signs in order to avoid any kind of accidents. So, all these to be considered. Next one is monitoring and control of industrial substations. Monitoring and control in industrial substations. The first one is SCADA system, that is supervisory control system to monitor a real-time performance. To monitor a real-time performance and make adjustments to protect the substation operations. To do the substation operations. So, proper SCADA system should be there. And automation, second one is automation. Automatic switching and fault detection should be done. Automatic switching as well as fault. Switching means whenever there is any kind of fault occurs for longer period of time, the circuit breaker should open the circuit in order to protect the remaining devices. And if there is no fault, again we have to switch on the device. Though the switching on as well as switching off should be done automatically based on the fault current in order to protect the device and in order to increase the efficiency of the overall system. So, the substation can quickly react to the electrical faults as well as overloads. By using this automatic systems, we can quickly react to the different types of faults as well as the overloads. Next is telemetry. So, telemetry means remote sensors which send the data to central control rooms in order to attain a quick response to the irregularities, that is during the fault conditions. In order to react quickly or in order to immediately deactivate that particular device, we need to use a remote sensors. Next one is data logging, that is record keeping for fault analysis, system performance as well as maintenance schedules. So, proper recording of everything should be done, like the different types of fault analysis and the system performance as well as the maintenance schedules, time to time schedules. Everything should be maintained properly in a logbook. Next one is applications of industrial substations. Here you can see 4 different applications, that is heavy manufacturing plants, like we can power the large machinery, furnaces as well as robotic systems. The second one is chemical as well as petrochemical industries. The second one is chemical as well as petrochemical industries. It can supply stable and reliable power for complex processes as well as the equipment. The third one is mining. That is powering the equipment for extraction, processing and transportation in the mining operations. So, for mining industries also we can use this industrial substation. The fourth one is food and beverage industry. So, for ensuring the power for production, like refrigerating systems and for heating systems. For production lines, refrigerating systems as well as for heating systems, mainly which is used in food and beverage industry, we can use this industrial substation. Challenges in industrial substation. What are the different challenges which are being faced by this industrial substation? They are like, first one is overloading. That means the power demands may exceed or increase the capacity of substation, leading to an outages. That means the loads in the industry may increase suddenly or may increase suddenly or may decrease suddenly. So this sudden increase or decrease in the loads may affect the overall performance of the substation also. The second one is maintenance and upgrades. Where regular maintenance is essential to ensure the reliable power, and sometimes components need to be upgraded for increasing the capacity. That means the upgraded versions or the upgraded sensors should be connected during the regular maintenance time in order to increase the overall efficiency. The third one is environmental as well as noise pollution. The high voltage transformers and other components provide noise and have environmental impact also. As the industries work with high voltage, we need to connect a HT connection, that is high tension connection, where the voltage is very high and the high voltage transformers are being used, which will have more noise effect. So the noise effect also should be considered, and it has an impact on the environment also. Next one is safety risk. So the handling of high voltage equipment is very dangerous to handle the high voltage equipment. So safety risks are more in this industrial substations. So these are different types of challenges which are being faced by the industries. Future trends of industrial substations. What are the future trends? Like smart substations, that is integrated IoT based or automatic substations, which are nothing but the smart substations for real-time monitoring and for the fault detection. The second one is energy efficiency. By using the energy efficient transformers, better insulation and advanced control system can to minimize the losses. So by minimizing the losses, by using the energy efficient transformers as well as better insulation, the overall energy efficiency of the system can be increased. The third one is renewable energy integration. That means substations will increasingly connect with renewable energy sources like wind, solar and hydroelectric plants. Substations will increasingly connect with renewable energy sources like wind, solar and hydroelectric plants. The fourth one is decentralized power system. The smaller localized substations that allow for better load distribution and reduced transmission losses. So these are the four different types of future trends in the industrial substations. Summary. The summary is like, industrial substations are crucial for ensuring the reliable and safe power distribution to the larger industries or more number of industries, and proper design as well as safety and monitoring is also important. The future of the substation lies in smart technology and automation, where we can use the IoT system to increase the efficiency, and integrate with the renewable energy sources. In next topic, I would like to discuss about the transformer selection. Thank you.